Hello. Sorry for the delay. Problem number 16 says that prove that if the sequence an converges to a, then the sequence absolute value of an converges to a as well. It's going to be a hopefully quick and easy problem. So we'll start the proof off, and we'll start by assuming the sequence an converges to a, which I'll notate like that. Assume the sequence an converges to a, and then we'll just unpack the definition of converging, sequence converging. Then for every positive epsilon, there exists some natural number n such that for all little n greater than or equal to capital N, the absolute value of an minus a is less than epsilon. And so we get this sort of inequality. And if you're familiar with the reverse triangle inequality, we can essentially pull back on this inequality. And that tells us, so by the reverse triangle inequality, we have the absolute value of an minus absolute value of a is less than or equal to, essentially, this guy, which we know is less than epsilon. And so we get the desired inequality for the absolute value of an being convergent to the absolute value of a. Sorry, I should say that. Yes. Converges to the absolute value of a. All right, we have the inequality we want. So the sequence absolute value of an converges to absolute value of a. That's the proof. We can also think about the converse as well. So if the absolute value converges, does the sequence without the absolute value always converge? Well, a quick counterexample would be if we thought about the sequence an that's -1 to the nth power, because the absolute value of an would give us 1 always, so it would converge to 1, but we know that this sequence without the absolute values does not converge, so the converse is not true. That's problem number 16.